Hello everyone, good morning. Anyways, I am Lubo Marjolin C. And today, I will be going to share with you about how I differentiate these given functions. But first things first, let us recall the rules of the derivatives. So first one, we have here a constant rule. When you have any number, the derivative of that is equal to 0. Next one is the power rule. For power rule, you just need to bring down the exponent, copy the x, and deduct 1 to the given exponent. Third one is the constant multiple rule. For our constant multiple rule, it is something like this. You just need to copy the constant and for the multiply it to the derivative of this function. The fourth one is the sum and difference rule. For sum rule, we just need to get the derivative of the first function added by the derivative of the second function. And for the difference rule, the same thing, but you just need to deduct them. That you just need to deduct their derivatives. For product and quotient rules, for product rule, we have here, if you're given an item like this, you just need to use this formula. The first thing you need to do is, of course, to have the derivative of the first function multiplied by the second function, and you just need to add. Always remember that in product rule, you need to add them, not subtract, unlike the quotient rule. So add them to the first function and the derivative of the second function. Next one is the quotient rule. For quotient rule, we just need to deduct them. We just need to deduct the derivative of first multiplied by the second function, and the first function multiplied by the derivative of the second function. You just need to deduct them over the square root of our denominator. So that is the formula in getting the derivative of the quotient. Next one is chain rule. Of course, this is the easy part. In chain rule, you just need to get the derivative of the outer function first, and after getting the derivative of the outer function, you just need to multiply once. Always remember that once, you just need to multiply once the derivative of the inside function. Next one is we have here common function derivatives. Exponential function. When we have here ex, the derivative of that is itself. Okay? And if we have here 2x, you just need to 2 raised to the power of x, you just need to have this one. 2 raised to the power of x ln 2. Alright, this is applicable to all. When you have 3x, then the derivative of that one is 3x ln 3. Next one is we have here the logarithmic function. For logarithmic function, when you're given ln x, you just need to, the derivative of that is 1 over x. For example, you are given log 2x. The derivative of that is 1 over x ln 2. Okay? And lastly is the basic trig functions. When you are given sine x, the derivative of that is cos x. And when you're given cos, the derivative of that is negative sine. Tan sec squared, cot negative c sc squared, and sec x is sec x tan x, and lastly is csc x is equal to negative c x cot x. So that is the rules of the derivatives. So since we already know the rules of the derivatives, we can now answer these given equations. So first one here is the function is equal to 4x5 minus 5x4. So in getting the derivative of this one, again, we will use the power rule. So in power rule, we just need to bring down 5. That's why we multiply 5 by 4. That's why we come up with this 20. And we deduct 5 minus 1. So 5 minus 1 is equal to 4. That's why we come up with 20x4. And the same thing goes here. You just need to bring down 4. That's why we have here negative 20. And deduct 1 to 4, which we come up with x cubed. So the final answer or the derivative of this function is equal to f prime of x is equal to 20x4 minus 20x cubed. In this part, number 2, as you can see, we have here negative ex sine x. So in this part, we will use the product rule since it is multiplied. Our u here is ex and our v here is sine x. So in product rule, as I mentioned earlier, that in product rule we need to have the derivative of the first function multiplied by the second function. And that's why we come up here ex. Why ex? Because the derivative of e raised to the power of x is itself. That's why we copy ex sine x and copy the first function, and the derivative of sine x is cos x according to the trig functions that I've shown you earlier. That's why we come up with an answer f prime of x is equal to ax sine x plus ex cos x. Or you can also rewrite this into like this, because ex, you just need to get the ex outside and copy the sine x plus cos x since they have common, if you want the cleaner one, but this one also is accepted. Number 3, we have here f of x is equal to x4 plus 3x minus 1. Again, according to the chain rule, we just need to first differentiate the outer function. That's why to differentiate, we just need to bring down the negative 1 and copy the inside function, and negative 1 minus 1 is negative 2. Now, we need to multiply this into our inner function. So x4 plus 3x, the derivative of this one is, of course, 4x raised to the power of 3 plus 3, because 3 times 1 is equal to 3. So that is our final answer. Next one, number 4. This is a little bit different. So for our x4, we have here 3x squared times x3 plus 1 raised to the power of 7. Now, using the chain rule, we just need to bring down the 7. So 3x squared times 7 and copy the inside function, and 7 minus 1 is equal to 6. Now, to differentiate x cubed plus 1, we come up with 3x squared plus, why we need to plus this? Why we have plus? Because in this given, this is a product rule. We just need to use, in this item, we need to use product and chain rule. That's why we have here plus. Now for our plus, we just need to differentiate first. We just need to differentiate first the this function, copy and multiply this by 6x. So that is our final answer. Number 5, f of x is equal to cos 4x minus 2x. So in this item, we just need to bring down the 4. That's why we come up with 4 cos x raised to the power of 3, because 4 minus 1 is 3. And the derivative of cos cos x is equal to negative sine x. After that one, why is that there is negative 4 here? Because, again, the derivative of the second equation is negative 4. Okay? Because negative 4 times 1 is negative 4. That's why we have here negative 4. So that is our final answer. Number 6, item number 6, we have here f of x is equal to x over 1 plus x squared. So in this item, we just need to use the what? the quotient rule. Very good. So in using the quotient rule, we come up with an answer 1 multiplied. So to continue, we have here 6. Items number 6. So in this one, we just need to use the formula of the quotient rule. So again, we just need to have here the derivative of x is equal to 1. And let's just copy the denominator. And we deduct this by x, and the derivative of this, the denominator, is 2x. And over the square root of the denominator. So that is our final answer. Number 7, the same thing as what we did earlier, but we can simplify this one. So for our f of x is equal to x squared minus x, to simplify this, we can simplify this one because we have numerator x and denominator x. So 2 minus 1, we have here x, minus negative 1 over x. So to get the derivative of this one, this simplified version, we have here 1 plus 1 over x squared, or 1 plus x negative 2. So that is the same thing. Next one, number 8. We have here the f of x is equal to 3x squared multiplied by x 1/2. So in this item, we can rewrite this into 3x. In this part, why we come up with 5 over 2? Because we can add their exponents. So basically, when you add 2 plus 1/2, it is equal to 5 over 2. But if it is quotient, you just need to subtract their exponent. So this is the simplified version of our given. We have here 3x 5 over 2. So the derivative of this one is, we just need to bring down the 5 over 2. That's why we come up with 3 times 5 over 2 x 3 over 2. Why 3 over 2? Because again, we need to subtract according to the power rule. We need to subtract the exponent into 1. That's why our final answer now is 15 over 2 x 3 over 3 raised to the power of 3 over 2. So that is our final answer for the item number 8. Next one, item number 9. Now we have here the f of x is equal to ln x e raised to the power of 7x. So in this part, we need to use the log rule. The log rule, according to the log rule, we need to add the ln a plus ln b. If, as what you see, this is ln ab. So our a here is x and our b here is e raised to the power of 7 over x. So we just need to add them. Now, to rewrite this one, we come up with ln x plus 7x. Yes. So 7x, because that is 1 and multiplied by 7x is 7x. Now, the derivative of our given item is, we come up with 1 over x plus 7. Why 1 over x? Because as what I've said earlier, that ln x is, the derivative of it is 1 over x. Plus 7, because 7 times 1 is 7. So that is our final answer. For item number 10. For item number 10, we have here f of x is equal to 2x4 plus 3x squared minus 1 over x squared. So in this part, we can rewrite this one into this. 2x4 plus 3. Anyways, why we can rewrite this one? Because we have common terms, which is x. So 4 minus 2 is equal to x squared. 2. That's why we have here 2x2 plus 3. We can cancel directly the x2 and x2. That's why the only number that we have here is 3. And negative 1 over x squared is negative x squared. Why negative 2? Because why negative 2? Because 1 minus 2 is negative 2. That's why we come up here with x negative 2. So since we already simplified this one, it's easy for us to get their derivatives. So we have here the derivative of f of x is equal to x4 plus 2x minus 3. x4 because you just need to bring down the 2, that's why you come up with 4x plus 3. Our constant here will become 0. That's why we don't need to write them. And negative 2 multiplied by negative 1 is 2 plus negative 2 plus 1 is negative 3. So that is our final answer. So for this item, next one is we have number 11. We have here f of x is equal to x3 5 square root 2 minus x. So in this part, we just need to use the product rule. Our u here is x3 and our v is the square root 1. So according to the product rule, you just need to have the derivative of the first function first multiplied by its second function. So we come up with this. So 3x cubed times 2 minus x raised to the power of 1 over 5, because you can write this square root into exponent just like this. You just need to, the number 5 here, you just need to be your denominator. That is algebra. So yeah, that's easy. So you just need to know the algebra things before having calculus, because that is your foundation anyway. So you will learn this, but yeah. So you just need to add this into x3, copy the first function, and the derivative of the second one is you just need to bring down the 1 over 5. That's why we have here 1 over 5, 2x, and that's not negative anyways. That's positive 1 over 5. That's just typo or an error, but at least we able to see the error there. That's why, okay, bring down the 1 over 5 multiplied by 2 minus x, and negative 1 over 5 minus 1 is equal to negative 4 over 5. So that is our final answer. Next one, item number 12. We have here f of x is equal to 2x minus 4 over square root of x. So in this item, it's not easy to differentiate this one. That's why we need to simplify this first. So in simplifying this one, the square root, the denominator square root, we can write it this way. So we come up with f of x is equal to 2x minus 4x raised to the power of negative 1 over 2. Because if you rewrite this square root of x, it will become, the other exponent will become negative. So that is basic algebra. Anyway, so the derivative of this simplified version of our equation, we come up with f prime of x is equal to 2 plus y2x, because negative 1/2 multiplied by negative 4 is equal to 2. So we have here plus 2x minus negative 1 over 2 minus 1 is negative 3 over 2. So that is our final answer. For item number 13, it's a little bit challenging, but again, we just need to use the formula of the rules of the derivatives. For f of x, we have here 4 multiplied by 3x minus 1 squared over x2 plus 7x. So in this part, we just need to use the quotient rule and at the same time the chain rule, since as we can see, we have here a function. We just need to use a chain rule for that. So in this part, we have here the okay, so the derivative of our numerator. So the derivative of our numerator is equal to, it's not 24 anyways, because 4 multiplied by 2 is 8. So that's why we put there 8. So 8, 3x, copy the inside function, and let's multiply this by our denominator, and minus, because again, quotient rule is minus or subtract. We just need to copy the first function and multiply this to our And let's multiply this to the derivative of our denominator. So the derivative of our denominator is 2x plus 7x is not, I'm sorry for the typo, but it is 7 raised to the power of x. That's why we come up here with 7x ln 7. Because according to exponential rule, you just need to write this one. So this is over the squared of our denominator. That's why we have our x squared plus 7x squared. Okay, for item number 14, we have here f of x is equal to the square root of x squared plus 8. So in this one, we just need to rewrite it first. For our square root, we come up with an exponent 1/2. And the derivative of this is you just need to bring down the 1/2. That's why you have here 1/2. Multiply this by our inside function, and 1/2 minus 1 is negative 1/2. Now we need to differentiate first the inside function. That's why the derivative of this one is 2x. So that is our final answer. For item number 15, we have here f of x is equal to x over the square root of 1 minus ln x squared. So in this item, we just need to use the quotient rule. So in quotient rule, we just need to have the derivative of our numerator first, which is x. The derivative of x is 1. And multiply by its denominator, which is this one. Let's deduct it to x, and the derivative of square root of 1 minus ln x squared. So we just need to bring down the 1/2. That's why we come up with this. Negative 1/2 multiplied by 1 minus ln x squared raised to the power of negative 1 over 2. So the derivative of 1 minus ln x squared is equal to what? Negative 2, because the exponent here will be going here. Negative 2 ln x multiplied by, again, the derivative of ln x is equal to 1 over x. So over, of course, the square root of our denominator. So we have here 1 minus ln x, 1 over half. Sorry for the typo errors, but yeah. Let's over this to the square root of our denominator. So that is our final answer. For item number 16, we have here f of x over 6 over 3x squared minus pi raised to the power of 4. So in this one, it's very complicated when we differentiate this one. That's why we need to simplify this first. So in simplifying this item, we come up with f of x is equal to 6 multiplied by 3x squared minus pi raised to the power of negative 4. Because again, this 4 here, when you combine this, it will become negative. So now, it's easy for us to differentiate this one. We just need to use the chain rule. So in using chain rule, we need to bring down the 4. That's why we come up here with negative 24. Copy the inside function, and negative 4 minus 1 is negative 5. So the derivative of our inside function is 6x. That's why we have here 6x. So that is our final answer for number 16. For number 17, we have here f of x is equal to 3x squared minus pi, the quantity of 3x squared minus pi x raised to the power of 4 over 6. Now, in simplifying this one, we come up with this 1 over 6 multiplied by 3x squared minus pi x raised to the power of 4. So since we already simplified this item, it is easy for us to differentiate this one. So in differentiating this one, we just need to have 1 over 6, that is our constant. We need to use the bracket so that our 4, bring down the 4, and let's multiply this by our inside function, and 4 minus 1 is equal to 3, and the derivative of our inside function is 6x minus pi. So that is our final answer. For number 18, the same thing as what we did earlier. We just need to simplify this item first and before we differentiate this. So since we already simplified these items into this one, our 5 here will become negative 5. We have to use our product rule. So in using our product rule, we come up with this one. The derivative of x is 1. Derivative of our denominator is x squared plus square root of 3x raised to the power of negative 5. And the derivative of our denominator now is equal to this one. Negative 1. Okay, so the derivative of our inside function is 2x plus 3 over 2, 3x. So that is our final answer. So the same thing goes with this one. In this part, we just need to use the chain rule. So in using the chain rule, we come up with this. You just need to bring down the exponent, which is the pi, copy the inside function, and pi minus 1. So we come up with the derivative of our inside function, which is x negative x multiplied by ex and 1 plus x. So our final answer now is pi x. We just need to copy them and have this one. Or you can also have like this. Okay, so for item number 20, this video is kinda long. We just need, as long as we understand the concept, it's better than ever. So in this one, the derivative of the quantity of arctan multiplied by 2x over 10. We just need to bring down the 10. That's why we come up here with 10 arctan 2x, 10 minus 1 is equal to 9. And we multiply this item. Since we are using the chain rule, we multiply these items by the derivative of the inside function. So the derivative of the inside function is 1 over 1 plus 2x squared. Why? Because according to the formula of getting the derivative of arctan, it is this. So 1 plus 1 plus 2x squared. So that is the formula. And the derivative of 2x is basically 2. That's why our final answer is 10 arctan multiplied by 2x raised to the power of 9 multiplied by 2 over 1 plus 4x squared. So in differentiating, you can also simplify your answer. So number 21. So for item number 21, we come up here with f of x is equal to the quantity of e2x plus e 1/2. So in differentiating this item, we just need to bring down 1/2 according to the power rule. Bring down 1/2 multiplied by the inside function raised to the power of negative 1/2, since 1/2 minus 1 is negative 1/2, and the derivative of our inside function is 2x. 2e2x, okay? Because you need to bring down the 2, that's why you come up with this, and you just need to copy the e2x. And our e here will become 0 because that is constant. That's why we don't include that one. So our final answer is this. For item number 22, we have here f of x is equal to x4 plus 1 raised to the power of 5 multiplied by the quantity of 4x plus 7 raised to the power of 3. So in this part, we need to use the product rule. Why? Because we have here first and second. We see in the given equation that it is multiplication. That's why we need to use the product rule. We just need to add the derivatives of the first function multiplied by the second function and the derivative of the second function multiplied by the first function. That's why we come up here. We have here 5 multiplied by the quantity of x6 plus 1 raised to the power of 4. And in this part, there is a chain, as you can see. That's why we need to get the derivative of the inside function. So the derivative of the inside function is 6x. Now let's multiply this with our second function, which is 4x plus 7 raised to the power of 3. Since we are using the product rule, we need to use the sign plus. It is sign, it is addition. And the derivative of our we just need to copy our first function, which is x plus 1 raised to the power of 5, and let's multiply this by the derivative of our second function. So let's bring down the 3. That's why we come up here with 3 multiplied by 4x plus 7, and the derivative of 4x plus 7 is basically 4. That's why we need to multiply this into 4. So that is how we solve this kind of function. So for item number 23, we have here f of x is equal to 7x plus the square root of x squared plus 6 raised to the power of 6, the quantity. Okay. So in this part, we just need to use the chain rule. So according to the chain rule, we just need to have the derivative of the outside first, multiplied by the derivative of the inside. So in this item, we have here, we need to bring down the 6 and copy the inside function. So 6 minus 1 is equal to 5. So we need to get the derivative of our inside function. So the derivative of our inside function is 7 plus 1/2. Why 1/2? Because the square root is 1/2. And we need to bring down the exponent as well. That's why we come up here with 1/2 multiplied by x squared plus 3 and x squared plus 3. And 1/2 minus 1 is negative 1/2. So as you can see, we still have here inside function. That's why we need to get the derivative of this one. So the derivative of x squared plus 3 is basically 2x. That's why we have here 2x. So that is our final answer. For number 24, it's kind of difficult, but we can answer this one. So in this part, we just need to recall or use again the quotient rule since this is division. So in order for us to easily identify the this item, we can rewrite this into like this. So for our quotient rule, we need to multiply the derivative of our first and the second function and minus the first and last. Okay, so in this item, the derivative of our numerator is this one. We have here negative x raised to the power of negative 2 minus negative 2, negative 3. You just need to use their denominator in order for you to come up with these answers. And yeah, let's deduct this to its, let's just copy this without the derivatives and the derivative of our next function. That's why we come up here over the square root of our denominator. So for item number 25, we have here f of x is equal to the square root, cube root of x squared minus 1 over square root of x over 3. So in this item, we just need to rewrite this in order for us to simplify this easily or differentiate them easily. So the simplified version of the given function is f of x is equal to x 2 over 3 deducted by x negative 3 over 2. Alright, so it is easy for us now to simplify these items. That's why we come up with f prime of x is equal to 2 over 3. You just need to bring down the exponent, copy the x, and deduct it to 1. That's why we come up with negative 1 over 3. Plus, why plus? Because negative times negative is positive. So we have here plus 3 over 2x, and negative 3 over 2 minus 1 is negative 5 over 2. So that is our final answer for item number 25. So for item number 26, we don't need to be confused when it comes to radicals. We just need to simplify them first. So in simplifying this item, we come up with this. As you can see, it is 1/2. And it is now easy for us to differentiate this equation. So you just need to bring down. In this part again, we need to use the chain rule and product rule. So for chain rule, we just need to bring down the 1/2, copy the inside function, and deduct the 1/2 to -1. That's why we come up with this. And let's multiply this to our let's multiply these items to our quotient. Let's use the quotient rule in multiplying the inside function. So in multiplying the inside function, we come up with the derivative of the numerator, which is 2, multiplied by the denominator, and let's deduct it to our numerator and the derivative of our denominator, which is 7. So over our the squared of our denominator. So that is our final answer. Now, always remember that when you have this, you just need to simplify first and use the chain rule and multiply this into using the quotient rule. All right, because there is a division there, and we need to differentiate that one as well. So in number 27, it is basically easy to answer when you memorize the trigonometric function. So sine over cos is equal to tan. So sine x, the derivative of sine x over cos x is basically tan. This is tan x. Okay, so the derivative of tan x is sec squared x. So that is our final answer. Always remember that sine over cos is tan and the derivative of tan is sec squared. For item number 28, we have here and this one. So in this item, we just need to use what? What? All right. All right. In this item, we just need to be what? Okay, I will just explain to you how I'll come up with this part. All right. So in this item, there is a need for us to use the product rules. It's, as you can see, there is it is multiplication. That's why in using the product rule, the derivative of this one is x squared plus 3, and we come up here, we need to copy this one, x plus 4, 3x squared plus 3 plus 4, and the derivative of this one is ex to x, the derivative of our first, and let's add this to x squared plus 3 and ex. So that is our final answer. Let's just I'm quite confused with this equation, and let's just explore that one item later on. Next one is this. In this item, it is basically division. That's why we need to use the quotient rule. The derivative of our numerator is 10x minus 7, and copy the denominator minus copy the numerator, and the derivative of x squared plus 2 is 2x over the square root of our denominator. For our item number 30, we come up with this. Item number 30 of fx is equal to len times the quantity of 5x squared plus 9 over raised to the power of 3. So in this item, we need to use the chain rule. So in using the chain rule, we come up with this. We need to bring down the 3, copy the inside function, and 3 minus 1 is 2. And let's multiply this to our inner function, the derivative of our inner function. So the derivative of our inner function is, we have here 1 over 5x 2 plus 9. And the derivative of 5x2 plus 9 is 10x plus 0. So we come up with this item 3. The f prime of x is equal to 3 ln 5x squared plus 9 raised to the power of 2 times 10x over 5x2 plus 9. So for item number 31, we come up here with this. So as far as you can remember, the len is 1 over something, len over u. Our u here is 5x plus 9, and our v is the outer. So In differentiating this one, we come up with 1 over 5x squared plus 9 raised to the power of 3 multiplied by the derivative of, let's multiply this by our denominator. That's why we come up with 3, 5x plus 2 raised to the power of 2. And the derivative of our inside function is 10x. That's it. So that is our final answer. So number 32, we have here f of x is equal to cot sig x. So in this item, we just need to use the chain rule. So in using the chain rule, we come up with this chain rule because as you can see, there is what you call this parenthesis. So in using the chain rule, we come up with this. So the derivative of cot is negative CSC squared multiplied by 6x, and the derivative of 6x is 6. That's why we come up with this, our final answer. We don't need to, I'm sorry for this erasure because I also got mistake in answering this one. I forgot that it is chain, not multiplication, because there is no parenthesis here. That's why we need to be careful in answering the derivatives. We need to identify first whether we will use this equation with chain, with product, with quotient. That's why you just need to really understand what the function has given. So we can also write this, our answer, into this one. It is as a simplified version, but it is the same answer with this. It is much cleaner. So for item number 33, we have here f of x is equal to sec squared x multiplied by tan x. So basically, we have here dot. That's why we need to use the product rule. So in using the product rule, we need to have first the derivative of the first one. That's why we have here 2 sec squared x multiplied by that second function, and add this to our copy the first function, and the derivative of tan x is sec squared x. So our final answer is sec 2x plus tan x plus sec 4x, because sec squared x plus sec squared x is equal to sec 4x. You just need to add their exponent. That's why we come up with this answer. So for item number 34, arc sine. So always remember the formula in getting the derivative of the arc sine. So this one, the derivative of this is 2 raised to the power of x ln 2, because according to our exponential function, the rule of our exponential function, the derivative of 2 raised to the power of x is 2 raised to the power of x ln 2 over square root of 1 minus 2x over 2, because this is the formula of arc sine. So in differentiating this one, simplifying this, we come up with f prime of x is equal to 2 raised to the power of x ln 2 over the square root of 1 minus 4 raised to the power of x. So that is our final answer. So for number 35, we have here f of x is equal to tan cos x. So in this item, again, we need to use the chain rule. So f prime of x is equal to sec squared, because the derivative of tan is sec squared cos x, and the derivative of cos x is negative sin x. So that is our final answer. So for item number 36, we also have the f of x is equal to the quantity of x squared minus 1 raised to the power of 5 minus x raised to the over the quantity of raised to the power of 3. So in this item, we just need to simply use the chain rule or the exponential rule again. Chain rule and exponential rule. So we just need to bring down the 3 and copy the inside function, which is this one, and 3 minus 1 is 2. And the derivative of our inside function is 2x why we come up with 10x. Now, the derivative of this one is 2x raised to the power of 5. That's why we come up here with 10x. and we just need to copy the x squared minus 1 and the derivative of x squared minus 1. And since we have here negative x and the derivative of that is negative 1. So again, in chain rule, you just need to be careful with the exponents because it's kinda quite challenging. It's not challenging, but it's quite confusing. So again, in getting the 10x, you just need to bring down the 5 and bring down the 2, 10x. That is the derivative of the inside, and you just need to copy the inside function, multiply by negative 1. Where do I get the 2? Always remember that here, we have here the quantity of 2. So we need to bring down this 1, and bringing down this 1, we come up with 5. Bring down again the 5. That's why we come up with the 10x. And we copy the inside function and multiply by negative 1. Alright. So for number 37, we have here the f of x is equal to sec x sine x. So in this item, you just need to, as we can see, this is a product. This is multiplication. We have u here, which is sec x, and our v here is sine tx. So in this time, we just need to have the derivative of the first function, which is sec x. The derivative of that is sec x tan x. Copy the second function. And as you can see, we have here 3x. And we need to use the chain rule since there is a chain here. So the derivative of 3x is 3. Added by the let's just copy the first function. Let's just copy the first function and let's multiply it by the derivative of the second. The derivative of sine is cos 3x and multiplied by 3. So that is our final answer. So in this part as well, you just need to bring down use the power rule and the quotient rule. So in using the power rule and quotient rule, you just need to bring down the 3. That's why we come up here with 3 multiplied by x minus 2 multiplied by 1 because the derivative of x minus 1 is 1. And let's just copy the denominator added by the numerator multiplied by the derivative of our denominator, which is 4x, then x plus 3, 4 minus 1 is 3, and let's multiply this by the derivative of our inside function, which is 1. And over, of course, the square root of our denominator. And that is 38. So let's go with item number 39. So in item number 39, we come up with this. F of x is equal to log 5, 3x squared plus 4x. So in this item, again, according to the log rule, we just need to Okay, so in this item, the very thing that we need to do here, log 5 is equal to ln 5. And we need ln 5. It is 1 over ln 5. That's why, and we multiply this. Why we come up with this? Because visually, we can have, we have here 1 over ln 5 multiplied by the derivative, 1 over ln 5 times 3x squared plus 4x. So 3x squared plus 4x multiplied by the derivative of this one, which is 6x plus 4. So 1 plus 6x plus 4 is 6x plus 4, and you just need to copy the denominator. That's why we come up with this answer. So in problems 40 to 42, we just need to find the dy over dx. And let's assume that y is a differentiable function of x. So this is basically implicit differentiation. So whenever differentiating y squared and y, a5y, let's just multiply this to the prime of y. Because y is secretly a function of x. So y prime is a function of x. Always remember that one. So in differentiating this one, Again, we just need to multiply this by y prime. So first one we have here, 3y is equal to x e5y. So 3y prime is equal to e5y plus 5x e5y y prime. Why we come up with this one? Because this the derivative of this x negative 5y is negative 5y because x is 1. And we add this by this 1. Since we bring down the 5, that's why we come up with 5x e 5y. And let's multiply this by this 1. Always remember to multiply it by this. So we need to combine like terms. So in combining like terms, we need to transfer or transpose the 5x negative 5y y prime to the other side. That's why we subtract it to the 3y prime, and it is equal to e5y. So we just need to y prime for the outside, and let's combine these terms. Factoring, I guess. So we come up with y prime 3 minus 5x negative 5y, and x5y is equal to e5x. So our final answer for this is we just need to have this as our numerator and have this as our denominator. So that is our final answer. The same process goes with this item. Okay, you just need to differentiate each term first. Differentiate each term. That's why we come up here with xy, yxy, because this is a product rule. We just need to use the product rule with that. And this one, bring down the 2y multiplied by y plus 3x squared plus 0. So after differentiating each term, you just need to combine like terms. And after combining like terms, you just need to get the y in outside and make this as your numerator and this as your denominator. The same process goes with this item. It's kind of a long process, but it is the same thing. You just need to follow or differentiate each term first and combine like terms. So lastly is 43 to 48. Now, if f and g are differentiable functions such that f of 2 is equal to 3, f prime of 2 is negative 1, f prime of 3 is equal to 7, and g2 is equal to negative 5, g prime of 2 is equal to 2. Let's find the numbers indicated in problems 43 to 48. So in this item, we have here the quantity, the prime of g minus f of 2. So in this part, we just need to distribute 2 in each item. That's why we have here minus. So g prime of 2, we have here 2, and f prime of 2 is negative 1. So 2 minus negative 1 is 3. That's why we come up with that answer. The same process goes with here. You just need to again, this is multiplication. That's why we need to use the product rule. And in product rule, we have here plus the derivative of the first function and the derivative of the second function. So you just need to apply their rules in order for you to get the answer. So after getting the formula of product rule, just need to distribute the 2 and found this number here. After finding their numbers, we come up, we just need to get the answer, which is 11. The same process goes as this. So this is quotient or division. That's why we need to use the rule or the formula of getting the derivative of this product. This one is derivative. That's why we need to use the derivative of this item. Quotient rule, I guess. So the quotient rule is this one. You just need to distribute the 2 and get their numbers here. After getting their numbers, you just need to simply equate them. And that's why we come up with negative 1 over 25. The same process goes as here. You just need, there are scalars here, as you can see. That's why you need to get their numbers. I'm sorry if I forgot to put the 2 here, but this is f prime of 2 and g prime of 2. And yeah, you just need to multiply the scalars into their given numbers. That's why we come up with answer number 1. The same process goes with here. Again, it is composition or composite function. So composite function, we just need to use the chain rule. So in using chain rule, we come up with this, the derivative of the outside and the derivative of the inside. So the derivative of the outside, we come up here, f prime f2, f prime f3 is equal to, the f prime of 2 is equal to 3, and f prime of 2 is, f prime 2 is 1. That's why 7 times negative 1 is negative 7. The same process goes with here. You just need to use the quotient rule, and as you can see, you have here f plus g. You just need to add them as well. So that is your denominator. So yeah, we come up with negative 1 over 4. So in this part, we need to use the power product and quotient rules as well. So the same process, you just need to use the power rule in this item and also in this item. And in this one, we just need to rewrite the square root of x into 1/2, as well as this 3 over 1/2, and rewrite this into this form. Negative 2, okay, because if you transpose it to the other side, it will become negative. Or, yeah, it will become negative. That's why we come up with negative 2. So that is our final answer. In this part as well, you just simply need to simplify them first, or to write them or rewrite them, because square root is kind of very confusing to get their derivatives. That's why we just need to rewrite this in their exponential form. That's why we come up with this answer. The same process goes with this one. If you will see, or if you will given an equation that is the same thing as this, you just need to factor them out. So the factor of x squared plus 7x minus 18 is x plus 9 and x minus 2. So we just cancel the x plus 9. So we come up with f of x is equal to x minus 2. So now it is easy for us to get the derivative of this one, because x minus 2, the derivative of this is basically 1, because our constant will be 0 and our x will be 1, and 1 minus 0 is equal to 1. So that's why we come up with this answer. The same process goes as number 6. And for our number 7, we just again we just need to simplify them first before getting their derivatives. So 2 minus 1, we just x minus 3 divided by 2x 1. You just need to distribute this into their term. After distributing this, you just need to perform the rules and get their derivatives. The same process goes as here. You just need to rewrite them, and you can really distribute this because all of the items have x. Okay, so the same process for this item. This is basically multiplication. That's why we need to use the product rule in this part. So the derivative of the first function is negative 6x minus 4. Copy the second, copy the first function, and the derivative of sec x is sec x tan x. That's why we come up with that answer. For item number 10, the same process. It is multiplication. That's why you just need to use the product rule. As well as this one. Our u here is negative 7x cubed, and our v is negative ax. So you just need to perform the product rule. The same process goes with number 12. And the same process goes to number 13. In this one, in this part, you just need to get the derivative of each term. just get their derivatives. Okay, so the derivative of this one is EX multiplied by 2X plus 4X. Why 4X? Because to bring down the 2, we come up with 4X. 15, we just need to use the quotient rule in this part. And for number 16, quotient rule as well. For number 18, we just need to perform the quotient rule as well. And it's advisable for you to simplify your answer. This one, we just need to use the quotient rule as well. And as well as this one. So for number 20, the same process, you just need to use the chain rule. So, I mean the quotient rule. So in this part, chain rule worksheet. So in this part, let's find the derivative of each function using the chain rule. So in chain rule, again, you just need to differentiate first the outside function, and after differentiating the outside function, you need to differentiate the inside function. So in this part, we bring down the 3, copy the inside function, and 3 minus 1 is 2. And the derivative of 2x squared minus 5x is 4x minus 5. This one. So that is our final answer. For number 2, we just need to rewrite this radical form into 1/2. And for that, it is easy to us to differentiate this part. So bring down the 1/2, copy the inside function, and deduct it into 1. And the derivative of the inside function, which is 15x squared minus 2. So that is our final answer. You know what? Using chain rule is really easy. Now, when is the moment that you will use chain rule? When you see an item like this, there is a parenthesis, parenthesis, parenthesis. Everywhere parenthesis. That's the moment that you will use the chain rule, okay? Because it's a chain. They are connected. So in this part, again, you just need, since we have here the constant, we need to use the constant multiple rule. Constant multiple rule, copy the constant, and the derivative of sine is cos. Copy the inside function, and the derivative of the inside function is 1. For item number 4, the same process. Why I came up with 2 sine? Now in this item, I came up with this 2 sine because the derivative of cos is negative sine, and negative 2 times negative sine is positive. That's why I came up with 2 sine. Copy the inside function and multiply this by the derivative of the inside function, which is 2x. So that is our final answer. For item number 5, we come up here with this one. So again, we just need to use the chain rule. So this is quite confusing. That's why we need to rewrite them. So in writing this one, we come up with the quantity of sine 3x squared raised to the power of 2. So it is now easy for us to differentiate this since it's quite clean. So we bring down the 2. That's why we come up with we copy our inside function. And the derivative of our inside function is cos 3x squared, and the derivative of 3x squared is 6x. So our final answer, we can basically multiply 6x to 2. So 6x multiplied by 2 is 12x sine, copy, and copy. So that's our final answer. The same process goes as this one. You just need to rewrite them and get their derivatives. Copy, bring down the, and as you can see, there is a sec squared x plus 2, and the derivative of sec squared is tan x minus 2, and the derivative of x minus 2 is 2x. And that is our final answer. You just need to multiply the 6x, copy all the remaining item. So in this item, as you can see, it is multiplication. Our first variable, our first function is 3x cubed, and our second is negative 2x minus 4. So in this item, it's quite confusing, but let's use a product rule in this part. So 3 times raised to the power of 3 is 9. x squared, 9x squared, copy the second, add them to 3x squared multiplied by, the derivative of this one is 2e 2x minus 5. Why? Because we need to bring down the 2 and copy the item. Alright, we don't need to bring down all of them, just the 2. So, in rewriting this, for it to be much cleaner, we need to rewrite this in this way. We just need to multiply the 3 times 2 is 6x and copy the e. The same process goes with this part. But in this part, it is ex raised to the power of 2. It's quite confusing, right? That's why we just need to get the derivative plus, and the derivative of this one is, the derivative of ex plus 2 is basically 2x. The derivative of this one is 2x plus 3. We just need to get the derivative of their exponent. So yeah, that is number 8. And for number 11, the same process goes with here. For item number 11, we just need to rewrite this item into this form. We just need to differentiate first the outer function. That's why we come up with here. And yeah, multiplied by this part in order for this not to be negative, we come up with this 3 over 3. Copy this one to our numerator and this as our denominator. The same process goes with item number 12, number 13. For our number 14, we come up with constant x. So we just need to use the chain rule. So in using chain rule, the derivative of cos is negative sign, and derivative of our inside function tan x is x squared x, and our x is 1. That's why we come up with this answer. So the same process goes with the following items. Okay, so for our next equation, we have here item number 22. For item number 22, we just need to differentiate, use the chain rule. That's why we come up with this for 3. Our inside function is 2. Yeah, you just need to answer that way. And our final answer is f of x negative 16 cot x 2x plus 2 raised to the power of 2. So the same process, you just need to use the chain rule, and you just the advice that I can give you is you just need to simplify or rewrite the equation first. It is, if there is radicals, you just need to rewrite it into its exponential form and use the chain rule. If you can see the parentheses, you need to differentiate that one. So for our item number 28, f of x is equal to 2e for x. For x here is our exponent. That's why we need to differentiate this. So in differentiating e for x, we come up with this one. We can rewrite since it is exponent, we can rewrite these items into this one. And let's multiply this by the derivative of our exponent, which is 4e for x. So that is our final answer. So I hope that you learned something in this video. And yeah, I just explaining my answers because this is what I'm tasked to do. So always remember the derivatives rules in order for you to easily get it is easy for you to differentiate any functions that are provided to you. So that's all for this video. I hope that you learned something. Anyways, I am Lubo Marjelinci, and thank you for watching.